In class example 1.13, we'll be given an original graph and its transformed graph. We'll need to determine the translations that have taken place, and then we'll write the equation of the transformed graph. In our first example, we see the original graph in blue and the transformed graph in green. By looking at the leftmost endpoint, we can determine that the graph has been shifted 2 points to the left and 3 points up. Remember that when we're writing a horizontal translation, if we've gone 2 left, we will write it with an addition. So when we write g of x in terms of f of x, we write g of x equals f of x plus 2, that's our translation left, and then outside the bracket plus 3, which is the translation up by 3 units. In this moment, if you're not sure what it means to write in terms of f of x, simply it means we're only describing how the new transform graph compares to the original in terms of transformations. So this is not something we'd be able to type into a graphing calculator and use to generate a graph, because the calculator would not know what f of x represents. And in fact, this f of x, we could call a piecewise function, would need multiple parts to describe it. Notice for the mapping rule how the vertical translation of plus 3 appears as y plus 3, but that the horizontal translation of 2 to the left appears as x minus 2, different from how it appeared in the equation. It will always be the case that the mapping rule will match our verbal description. The equation will appear opposite for horizontal transformations. In our second example, we see a cubic function, f of x equals x cubed, which in its transformed version appears 4 units to the left. Now in part 1, we will again write our equation in terms of f of x. So since the only transformation that's happened here is the translation 4 left, we would write f of x plus 4. However, in part 2, we're actually asked to write the equation in terms of x. That means we need to write something that could be typed into your graphing calculator and would generate the graph of that green g of x. So here, basically we're replacing the x that was cubed with an x plus 4 that will be cubed. Notice again that we're applying the plus 4, the translation, inside the bracket because it is horizontal. If we wrote x cubed plus 4, that would be a vertical transformation. Our mapping rule describes the verbal description. So since we moved 4 to the left, we say that xy maps to x minus 4 and y. In our third example, we have a square root function, which has been moved 2 units up and 1 unit to the right. So when we write the equation of g of x in terms of f of x, we will show 1 to the right as x minus 1 inside the bracket, and 2 up as the plus 2. So we'll write f of x minus 1 plus 2. Notice in the second example, we had no cube, no exponent of 3 on this line, and here we have no square root written. In the second line, where we're writing g of x in terms of x, now we will write it as a square root function, whose vertex is at 1 and 2. So we write it as g of x equals the square root of x minus 1 plus 2. Again, the mapping rule will match the verbal description, so 1 to the right is x plus 1, and 2 up is y plus 2.